I'm going to be talking about FVM, the Filecoin virtual machine, an IPC interplanetary consensus, and a quick demo of a data DAO, just to give you an example of what you can build on top of some of these technologies. So, quick recap, the Filecoin master plan, build the world's largest decentralized storage network that we have managed to do and are continuing to do. The network is about somewhere between 10 and 12 exabytes of size. Onboarding and safeguarding humanity's data, that is what we're working on at the moment. Onboarding data at a rate of about 40% increase per month. They're about, I think it's about 1 exabyte of data they've got stored on the network at the moment. And then the third part is bringing compute to the data and enable web scale apps. And like I said, I'm going to be talking about data DAOs. Ali's going to be talking about LilyPad and compute sort of off-chain, on-chain bridges. So, one of the ways you could think about this is IPFS. If you've used IPFS, you can kind of think of IPFS as kind of before the blockchain. So below that dotted line, IPFS is a decentralized way of storing data. Many of you may have used it, especially if you're using anything like NFTs. That is kind of sort of pre-blockchain kind of level. And then we have Filecoin at sort of layer 0 as a storage layer. And then if you think about conceptually compute over state rather, with FVM as kind of being layer 1, and then layer 2 being kind of performance and scalability on top of that. I'm not talking layers as in kind of layers specifically of a blockchain, but sort of more on a conceptual level there. So this is kind of like the evolution of the storage system from IPFS, in which you have to sort of manually pin data, potentially pay a pinning service or run your own nodes in which to pin the data, up through various layers of evolution of that storage going on. FVM, the Filecoin virtual machine, delivers on-chain programmability. I'm here, my colleagues Sarah and Longfei Wave also here, and Nikki as well. Sarah and Longfei also with me on the developer experience team. We will be at the Filecoin booth, so further questions you can come and find us talking about FVM stuff there. It is Ethereum compatible, so you can deploy Solidity smart contracts directly on top of Filecoin. That's going to show. I'm going to show that in a little bit. It's designed. I'm going through this fairly quickly so I can get to the demo, and we're a little behind on time. So the virtual machine allows, like I said, the execution of smart contracts on top. It actually enables various different runtimes. We're going to concern ourselves mainly with the Ethereum runtime on top of there, because that's the first one we've built. There's a couple of resources here. This QR code will take you to some information about using one of our partners, Lighthouse, that is a storage aggregator. And that is, in short, because Filecoin is designed to store large amounts of data. If you have small amounts of data, the storage providers are not interested in that. They want large amounts of data. So there's a number of storage aggregators that will take smaller pieces of data, bundle them up, and then pass them on to the storage providers. So it's likely you're going to be using somebody like Lighthouse or Web3 storage, NFT storage as part of your submission if you're doing stuff with Filecoin. Interplanetary consensus, IPC, that I mentioned. This is the notion of, okay, how do we unlock truly planet-scale performance for Web3? So it's horizontal scalability for Filecoin and Ethereum as well. It's actually chain agnostic, but we're sort of focusing on Filecoin initially. And it allows you to create subnets off of the main network that use a different consensus protocol, but then submit up to the main chain for final validation there. So you inherit the security of the main chain, but you have a much faster consensus process. So Filecoin is proof of space-time, IPC is BFT based and has a much faster block time. So a couple of seconds per block rather than 30 seconds per block on FVM. It's also hierarchical. You can actually create multiple networks off of each other. So you could have a layer 2, a layer 3, a layer 4, all chained off of each other as well. So this allows you to create these kind of hierarchies, and they might be represented. You might have a subnet specifically for, say, gaming, a specific use case. You might have a subnet based around a geographic region. So if you need people within a particular region to have higher speed access, as the block time gets down, obviously it starts to get more and more important. The actual latency within the network is kept low. So IPC allows you to have these regional subchains or custom subchains, even private subchains as well with that. And it's very customizable as well. That's one of the big things they're aiming for with IPC, that you could create a subnet with specific features enabled or disabled, specific block times, fee structures, whatever it is you want on there. There is a QR code that will take you through the documentation about using IPC. So IPC is something that's very, very cutting edge at the moment. We've been working on it. I suggest you probably don't use it for any submissions that you're doing here today. You can have a go, but there be dragons. Okay, so just a word of warning, probably best go with the main Filecoin network just for the moment, but this is stuff that is imminently available. So, and there's a, like I say, QR code there that will take you to a tutorial on how to deploy smart contracts to the testnet we have now called Mycelium, which is testnet on IPC. Use exactly the same tooling, hard hat remix that you would do with the main network. It's just a case of configuring to a different RPC endpoint. So an example of something you can build on here is something like a data DAO. This is what I'm going to give you a very quick run-through demo of. So the idea of this is to have some kind of smart contract that manages storage of data, right? So you might imagine that you have a endowment or some sort of system in which you want to say, we're going to manage the storage of a bunch of data. Then that smart contract could actually perhaps manage the funds for that data. You might have people contribute crowdfunding that then pays for the storage of that data. You might have within the DAO some sort of voting mechanism so that people can vote on what needs to be stored. Maybe it could be validated by a human before it is stored. Maybe the DAO could actually check certain things like, do KYC on the uploader of the data beforehand, right, to ensure that the data meets some particular regional regulatory requirement before it is passed on to the storage providers. So what we've got here is we have some data. I have taken a quick photo out there. I have then used the IPFS desktop client to upload that data, and it is on IPFS. You see there's a QR code. You might be able to just see there starting with, not a QR code, a CID, a content identifier, starting Q. That's actually slightly confusing in this demo, that's actually what's called a version 0 CID that starts with a Q. What you'll now see in a second are the version 1 versions that start with a B. It's the same thing, it's just in a slightly different format. I realized this just before the talk, that there are the two different formats, that might be a little confusing, but it is the same CID there. So I've uploaded that. That is now on the IPFS network via my laptop that is serving that up at the moment, right? We have a governor smart contract that's taken from OpenZeppelin. It's a standard OpenZeppelin governor contract for a DAO. And we then have a small contract, Lighthouse client contract, that submits to the Lighthouse data aggregator that I mentioned to you there. So we've pinned the copy on IPFS, it goes through the DAO, so we submit a proposal, we're then going to vote on it, we're then going to execute it, and then Lighthouse will then store it on Filecoin, right? So, Judah's running a little late on this. I'm going to walk through this. Hopefully you can see this. That QR code will have taken you to a GitHub repository. I've cloned the GitHub repository, the FEM Data DAO GitHub repository. I went in there, ran yarn install to install hard hat and the various dependencies. I then ran yarn hard hat deploy, and it has deployed those contracts. You see there's a governor contract there, there's Lighthouse client contract, and even a data governance token contract. So if we actually look in my MetaMask, I've actually got this data governance token down here that it's minted me as part of that deployment. So I've got a bunch of them to use for voting in this DAO. So that's it deployed, right? I can then run a proposal. So at the very top there, actually that's the vote there. Before that, there's a proposal command that you can run instead there. So I can run yarn hard hat propose, and I give it a CID there, which, oh yeah, thank you. Hard hat propose. So I can propose it. I can give it a reason. I've still got it wrong. Hard hat. There we go. Live demos and typing. Right, so I could propose it. That's a step I did just before, but unfortunately I realized I cleared my terminal just beforehand. It is now complaining because I've already just proposed that exact same CID, so that's why it's complaining there. Proposal already exists. So you'll have to just slightly take my word for it that in doing that, you then get a proposal that you can vote on, right? So I then voted, that's this top line, very top line here. I voted 1, which is yes in this case, against the proposal ID, which comes back from when you do that propose step, it comes back with a proposal ID, and I gave it a reason for my vote, which is hello Istanbul, and that is then proposed, right? And we can see here proposed, current proposal state 1. So this contract just needs 1 vote to approve it. You could set a threshold or a certain percentage number. I've just said we just need 1 here. And then once that's gone through and the voting period is finished, in this contract, the voting period is just set to 3 minutes, just for demo purposes. So you'd actually propose it. And then once that 3-minute time is up, you have to vote within that 3 minutes. You can then execute it. So you then give it the CID again and the reason, and it will execute, right? And so that then means it has now been passed on to the contract for Lighthouse to then store it. And I can actually look. There's a block explorer called Filecoin, and if I look at the transaction and look at the logs, we'll actually see for my transaction this submit aggregation request with RAS. That's the event that has been emitted after everything has been executed that Lighthouse is looking out for. So now when Lighthouse sees that, they will fetch the CID. The CID is actually encoded here within the data. That'll be the hex representation of the CID. Takes that CID, goes and fetches it from IPFS, and then stores it on the Filecoin network. And the result will be at the end of that what's called a deal ID. So when it gets picked up by a storage provider, which may be an amount of time later, I think it's about half an hour at the moment, I think they're going at the moment. Yeah, so it's about half an hour. You will get back a deal ID, and that is the bit that assures you that the data has been now stored on Filecoin. And then you'd be able to look in here and look at the deals, and you can actually see a deal here. I'm just going to pick a random one. But you'll see the deals. He says, oh, deal list. Or not, if the network's not going to let me load it. But you would get a deal list. No, it doesn't want to show me deals. Okay. Yeah. Anyway, you'll get a list of deals, and from there you'll be able to see which deal. Okay, so one of those deals, then once it's been accepted, you'll be able to see it here and see that it's been taken by a particular provider and stored on the network. Okay? So, I think that's it then. Right, that was very whistle-stop tour. Like I said, you can come and find us at the booth or chat to me after this if you want to find out more. Now I'm going to hand over to Ali to talk about LilyPad.
I'm Ali. You might have seen me before around the Filecoin ecosystem as well. Super excited about this project. Richard is here as well to help on this project. Quick overview. We're creating kind of this global permissionless distributed compute network, which enables internet-scale data processing. So we're trying to, especially in Web3, create a way for you to build these really web-scale dApps now. And you can do this from smart contracts or from a CLI, but you could call these functions from smart contracts, which really gives a lot more functionality to your dApps as well. Yeah, practical terms, run AI and other compute workloads. I'm just conscious of time here and I want to get to the good stuff. So basically, we're aiming to enable you to run AI and other compute workloads in this decentralized kind of crowd compute that we're calling it, or crowd cloud that we're calling it a little bit. And you have access from the CLI or from smart contracts, or we've also got a web interface now, which will eventually have an API key, so you could use this like a Web 2 project, but it'll actually be a decentralized cloud in the background. So why are we doing this? Well, if you have a look at the state of the compute at the moment, it's pretty much controlled by a handful of companies at the moment, which isn't really great. Like, that creates an oligopoly. That's not good for outcomes of technology and society, basically. And it's the same for the state of AI at the moment. These same powerful players that have access to like this vast amounts of data and this powerful compute hardware also currently dominate this AI space, and they're even pushing for regulations at the moment that essentially mean that all AI models should be closed source and proprietary, which for all of us in this open source world is probably like just what? You know, this OpenAI Dev Day, it was cool. I watched it, very Steve Jobs. And they're creating some amazing stuff, and I use ChatGPT every day, but we should probably be pretty wary about how vertically integrated this AI model is getting, considering how much we are going to use it and rely on it, or how much good it could do in the future as well. So given this immense potential, we need to try and decentralize this AI stack, and that includes decentralizing the compute stack, because that's currently a bottleneck to creating good competitive AI models as well, or running AI models. So let's dig into how we're making this happen. So Lilypad combines this off-chain compute implementation while providing on-chain coordination. It's built in Go and Solidity, so it's fully EVM compatible. It uses its own ERC token called LP to pay for services and gas, and it's deployed on IPC, and we've also recently deployed to Sepolia and Polygon as well, if you want to try those out. So how do you use it? You can use it via, like I said before, the Lilypad CLI. You could also use it via your smart contract, so you can call a function directly from a smart contract. And we've just released the Lilypad AI Studio, which is the web interface for this. And it's not available yet, but you'll be able to use it with API keys. So it'll be APIs and SDKs eventually. So currently, all jobs on the network are required to be deterministic, and we call them kind of modules. So each module is like a packaged compute job. So it's either a Docker repo telling it what to do, so run this Stable Diffusion model, or you can also use arbitrary WASM to create these. So you can have a look at our docs to see more on how you can create your own modules as well. So you can add your own modules, and in future you'll be able to like kind of charge a fee per job on your own module as well, which would definitely trying to bootstrap like this ecosystem of AI builders contributing to the project as well. So we've got some already on there, so you don't have to like do the hard work of creating your own module. We've got things like SDXL, which is like Stable Diffusion, text to image, the most recent release as well. So it's like really, really cool, Mid-Journey like Stable Diffusion. We've got Mistral on there, which is an LLM, so you can have a chat with this LLM. And there's also even fine-tuning on there. So you could fine-tune an image fine-tune a model for your purpose. For example, you could pass it in a bunch of like docs on Filecoin and fine-tune an LLM model to work with that, which is pretty cool. I'll show you how it works. To get started, you just have to add the Lilypad Aurora network to your wallet, usual flow. Get some testnet tokens from the faucet here. And then if you want to use the CLI, so in your terminal or on your computer, you just install it. There's instructions in our docs to do this, but it's just a couple of lines of code to install it. And then you put in your private key here into your CLI. You're only telling your local machine this private key, so don't worry. And then you can go ahead and run different modules. So this is also a YouTube video of how to set up there, so if you need some help on that, and also how to run like Stable Diffusion, text to image, if you want to like go back and have a look at that too, and you're more of a visual learner. Next, please, slides. Right. Okay, so after installing, this is kind of our hello world. This isn't really AI, but this is like kind of our hello world. We've used Cowsay for that. This was our first ever module. Bit of fun. And Rick even turns up in this module, so it's pretty cool. Anyway, this is just a tester, so you can run something like Cowsay and see you just get a cow. But it's as simple as like putting this one line of code in, and then Lilypad will run on this distributed network, like it submits the job to the network, a node will pick it up, run the job and return the results as an IPFS CID and also to your local folder too. Same with the Stable Diffusion text to image prompt. So you can do Lilypad run SDXL and get a lovely unicorn here. Now, because we're deterministic, you will get the same image if you put the same prompt in every time. If you do want to change that, you can change the seed. So you'll be able to do prompt equals an astronaut riding a unicorn and then seed equals a different seed number and you'll get a different result there. So how about fine-tuning a model? This is pretty cool, actually. So we've just implemented fine-tuning with SDXL. You can pass it in a CID. So in this case, there's an images CID getting passed in. So perhaps 50 Monet images are passed into this IPFS CID. And then a model can be fine-tuned to work on this Monet images. And then if you go, this isn't a Monet image, but as an example. And then if you went and ran this with a prompt, so the next bit would be running the inference on it, on your own model that you just made, model. And you would get like kind of a Monet version of a dog. I've seen enough cats, so like I thought I'd do a dog today. You can also use it from smart contracts. So I won't do a demo because we're kind of a bit low on time today. But this is all up in the docs as well. Just use it from Remix. You put a couple of functions into your own smart contract and you'll be able to run the job, and when it returns, you'll get a result CID into your smart contract. Heaps more modules, as I kind of showed you earlier. This is what the AI Studio web interface looks like. So just very Web 2 flow for that one. Probably not useful for developers here, but it's still cool. Anyway, and then some things you could use it for. So I think Web3 is really good at unlocking network effects. And as I said earlier, like trying to create this actually open AI environment. So I'd love to see what you could build around, kind of where Web3 helps AI solve some of its problems that are cropping up, like provenance or proof of humanity or attribution models as well. And kind of speaking of attribution models, we created a POC called waterlily.ai, which is a generative AI art platform that kind of addresses this attribution problem. And under the hood, this actually uses Lilypad. So what you do is an artist will upload their works, we'll train a model to it, and then a user would come along and go, hey, I want some stable diffusion images based on Monet, like I was saying earlier, pay a small fee. And that small fee, some of that goes back to the original artist. In the case of Monet, because it's public works, it goes to a charity. But as an example, this is kind of an interesting POC to think about. So some hack ideas as well. We'd love to see some dev and user tooling because we're really in beta stage here. So it would be great to see some dev and user tooling get made for Lilypad. And like I said, I'd love to see the crossover between AI and crypto, some of your dApps and end user projects as well. If you need more inspiration, have a look at our docs. There's a bunch of past projects people have done at hackathons, which will be interesting to look at as well. And otherwise, get in touch with us. We'd love to see what you build. We'll be around the booth as well, so ask us questions. And thanks, everyone.